We started with a problem. A problem within the Engineering Hardy Lab. Frequent misuse of the workshop often leaves the floor littered with tennis balls. This leaves the supervising head of the lab, Mike, displeased. His valuable time is wasted tending to the cleanup of the room, transporting a heavy bin to each ball individually. So we set out to help Mike, to help bring the tennis ball to the bin. We started with research, combing through existing patents and solutions, discovering 4 main limitations to most designs. They are either too bulky, not freestanding, lack a suitable trigger mechanism to store energy, or only have one firing setting. This led us to the ideation process, considering 5 main ideas. The first design used an elastic beans to launch the tennis ball, with a scissor lift to provide a desired angle. Our second consideration was to use torsion springs to launch the ball. We anticipated a ball storage container would yield faster firing times, as the task of loading the ball into the firing mechanism would be left to gravity. Thirdly, we considered a design with an elevated height that mimics a baseball pitching machine. We thought that if we could elevate the height of the launcher, then we could increase the height and distance that our ball travels. Our fourth design considered using a main barrel to house the tennis ball in place. We would use multiple extension springs fastened to the back so as to provide the necessary launching force needed. A mounted hook would act as a lever to minimize the amount of force needed to fire the projectile. Lastly, we considered a simple design of which consisted of an elastically powered launcher with 2 hinge points and a pin-based firing mechanism to store our potential energy. Using weighted objectives and a selection matrix, we concluded our barrel gun design best met our criteria. Using SOLIDWORKS CAD software, we were able to fully specify the details of our design and proceed on to fabrication. The simplicity of our design made it very easy to build, requiring little materials in the workshop. Simple tools like the bandsaw and a disc sander were enough to create most of our parts. And only under 3 instances did we ever need to use a complicated laser cutter. A simple protractor mounted on the side of the barrel provides various reference angles for the user to shoot at. The feet of the legs also serve as handlebars to carry the device from place to place. We conceived a design that is minimal, lightweight, cheap, and compact. The versatile legs allow for many orientations for convenience, and requires very little storage space when the device is not in use. When testing, the ball was well able to make our criteria of 6 meters. Even though the ball can go further in some instances, this is suitable for Mike. So in meeting objectives and constraints, we made a solution that is simply better because it is simple.